Welcome to the DIY Honda Garage channel. The issue presented pertains to the Diagnostic Trouble Code DTC P2237, indicating a problem with the air-fuel AF sensor 1, specifically pointing to a high voltage condition in the AF sensor circuit. This sensor plays a vital role in monitoring the air-fuel ratio in the engine's combustion process. It is located in the exhaust pipe, downstream of the engine, and before the catalytic converter. Proper functionality of the AF sensor is crucial as it directly impacts engine performance, emissions control, and fuel efficiency. A malfunction in this sensor could lead to poor engine operation and increased harmful emissions. The vehicle's powertrain control module, PCM, uses signals from the AF sensor to adjust fuel delivery and ignition timing. In this troubleshooting process, it is essential to determine whether the issue is persistent or intermittent and correlated with any other symptoms observed. DTC P2237 indicates a confirmed malfunction in the AF sensor, sensor 1. The high voltage condition in the AFS circuit means that the voltage reading from the sensor exceeds acceptable limits, which could disrupt the proper air-fuel mixture that the engine requires for efficient operation. The AF sensor is located in the exhaust system, specifically positioned after the exhaust manifold and before the catalytic converter, ensuring accurate readings of the exhaust gases coming from the engine. This placement allows the sensor to provide real-time data to the PCM about the air-fuel mixture being burned in the engine. When this sensor fails or operates improperly, it can lead to several ramifications, including reduced engine performance, increased fuel consumption, and elevated emissions. Therefore, diagnosing and addressing this error code is essential for maintaining vehicle efficiency and compliance with emission standards. There are several possible causes for the appearance of DTC P2237. Firstly, high resistance in the wiring connecting the AF sensor to the PCM can lead to inaccurate voltage readings, hence triggering this error code. Secondly, a short circuit in the AFS circuit could cause a surge in voltage levels, leading the PCM to register a high voltage condition from the AF sensor. This malfunction may stem from damaged wires, corrosion, or poor connections at the sensor or PCM connectors. Additionally, a faulty AF sensor itself can be the root cause, either due to internal failure or degradation over time. Identifying the exact cause is crucial to ensuring that repairs or replacements address the core issue, rather than merely masking symptoms. Thorough checking and testing of wires, connectors, and the sensor itself are necessary steps in this diagnostic process. When troubleshooting DTC P2237, several symptoms may be noted that could indicate the underlying issue. The most immediate and noticeable symptom is the activation of the check engine light, which alerts the driver to a problem with the vehicle's performance. You may also observe poor fuel economy, as the engine may run lean or rich due to incorrect air-fuel mixture readings, leading to inefficient combustion. Another potential symptom includes rough engine idle, where the engine may struggle to maintain a stable RPM, causing vibrations and decreased smoothness during operation. Other symptoms could include increased emissions, potential failure to pass emissions tests, and poor overall engine performance. Recognizing these symptoms early can assist in diagnosing the DTC more effectively and allow for timely repairs. The first step in troubleshooting DTC P2237 involves ensuring the vehicle is set to the on position without starting the engine initially. This allows the system to come online and prepare for diagnostics. Following this, you will use the Honda Diagnostic System, HDS, to clear existing DTCs. This is essential as it resets any previous fault. and allows for an accurate depiction of current error codes. Once the DTCs are cleared, the engine should be started and held at a stable 3000 RPM without any load until the radiator fan activates. This step ensures that the engine reaches operating temperature and the sensors perform in realistic conditions. After this process, you will again check for pending or confirmed DTCs with the HDS. If DTC P2237 reappears, it indicates that the problem persists. However, if it does not appear, it suggests an intermittent issue, and further investigation into connections and terminals may be required. In the second step of troubleshooting DTC P2237, begin by turning the vehicle to the off or lock mode, which is necessary for safe testing of electrical components without draining the battery. Utilize the HDS to jump the SES line, a method that establishes a diagnostic pathway, and wait for more than 1 minute to allow for any stored data to stabilize. After that, disconnect the AF sensor, sensor 1, 4P connector, and the PCM connector C, 51P, to ensure that the testing is conducted without interference. Following the disconnection, check for continuity between two specific test points: female terminal number 2 of the AF sensor, 4P, and number 48 of the PCM connector, C. If continuity exists, it indicates that the AFS plus wire is functioning correctly, and you can proceed to the next troubleshooting step. If continuity is absent, there may be an open circuit in the AFS plus wire, necessitating repairs to ensure electrical connectivity. The third troubleshooting step involves checking the continuity of the AFS line, essential for proper sensor function. Ensure that the vehicle is still in the off/lock mode, and the AFS sensor, sensor 1, 4P connector, and PCM connector C, 51P, remain disconnected. Check for continuity between female terminal number 1 of the AFS sensor, 4P, and number 47 of the PCM connector, C. This continuity test ensures that the AFS wire is intact without any breaks or faults. If continuity is confirmed, it indicates that the AFS wire is functioning correctly, enabling you to advance to further testing steps. However, if continuity is absent, it suggests there may be an open circuit in the AFS wire. This defect would necessitate immediate repair of the wire to restore proper communication between the AFS sensor and the PCM, ensuring the sensor operates within the required parameters. In the fourth troubleshooting step, the focus shifts to the AF sensor, sensor 1, itself. It is advisable to substitute a known good AF sensor to rule out any faults within the sensor unit itself. After removing the non-functioning sensor, reconnect all previously disconnected connectors to ensure a secure and complete electrical circuit. Then, turn the vehicle to the on mode to power up the system. Next, reset the PCM using the HDS, which clears previous learned data and allows the PCM to recalibrate to current parameters and conditions. Once the PCM is reset, perform the PCM idle learn procedure to allow the system to adapt to the new sensor and learn the appropriate idle speed and parameters. After completing these steps, check for any new pending or confirmed DTCs using the HDS to determine if DTC P2237 is indicated again. If it is, further investigation may include checking for authorized service information or substituting a known good PCM. The final step in the repair verification process for DTC P2237 involves confirming the status of the DTC after all troubleshooting and repairs are completed. Use the HDS to verify whether DTC P2237 is still present. If the DTC has cleared and does not return, it indicates that the steps taken to resolve the issue were successful. However, it is advisable to check other related systems and monitor any changes in engine performance to ensure that the vehicle operates optimally without related issues. Additionally, keep an ear out for any unusual sounds and monitor fuel efficiency and emissions levels. If any new or recurring issues present themselves, further diagnostic work may be warranted to address any underlying problems. Gathering this information can provide a comprehensive view of the vehicle's health after addressing DTC P2237. To prevent issues related to DTC P2237 in the future, regular maintenance of the AF sensor and its electrical connections is crucial. Implement a schedule for periodic inspections to check the sensor condition, wiring, and harness for any signs of wear, corrosion, or damage. Maintaining clean, tight connections helps reduce the chances of faults arising due to electrical issues. Additionally, it's essential to observe for any symptoms of engine performance disruption, such as abnormal idling, increased fuel consumption, or illuminated warning lights. By addressing these symptoms early and ensuring that preventative measures are in place, vehicle owners can mitigate the risk of experiencing the same DTC issues in the future. Furthermore, staying informed about recommended service intervals for parts related to emissions control will assist in maintaining a vehicle that adheres to performance and emissions standards. In conclusion, DTC P2237 signifies a high-voltage condition in the AF sensor circuit, indicating potential issues with the AF sensor or associated wiring. The troubleshooting process involves a structured approach of verification, continuity checks, and component substitutions to accurately diagnose and rectify the problem. It is essential to address the enhancements of the vehicle's operational performance and compliance with emissions standards throughout this process. Regular inspections and preventative maintenance can play a vital role in prolonging the lifespan of the AF sensor and preventing similar DTC issues in the future. Understanding the implications and symptoms associated with DTC P2237 equips vehicle owners to navigate more efficiently through potential repairs. By remaining proactive, you can maintain your Honda CRV's performance and ensure a reliable driving experience. Please like and subscribe to the channel. See you next time.